Hi dear children, how are you doing today? Welcome back to your online classes. I am Anushka, your computer instructor, and we will begin our computer's journey and we will have so much fun studying our subject. I know lockdown has been pretty hard on you, but we as teachers are trying our best to keep you occupied and busy with and imparting you knowledge as always. Okay, so today we will study our first chapter, which is Computer History and Generation. And for this we will be using our Kilobyte book series by PMP Publishers. Alright children, so let's go to page number 5 and begin our chapter Computer History and Generation. It's a very theoretical chapter, so whereby we will learn about all the different generations of our computers, about all the history of it, who founded things and stuff like that. So let's begin. So you know that computer means to compute, and computing means counting something. All right. So first of all we will learn about the concept of counting. In the very historical times, in the very ancient times, we used to count using our fingers, using our toes, stones, pebbles, and even bones. So all these things were used by people to count, right? In the course of time, but it became difficult to do bigger and complex calculations. However, they were not capable of doing the bigger calculations. So then what happened was people created some interesting calculating devices. So some 5,000 years ago, Chinese developed and invented this device called abacus. Simple calculations like addition and subtractions can be performed using abacus, and it is still in use in different parts of the world. So abacus is the way we generally teach our young children, very young, in kindergartens, to count. You must have seen that in your mathematics laboratories for sure. Then after abacus, in 1617, a Scottish mathematician, John Napier, invented a calculating device called Napier's bones. So what Napier's bones does is, this device is a set of rectangular rods marked with numbers on them. It was meant for simple calculations again, like addition, subtraction and multiplication of numbers. And later on it was improved to perform division and to find a square root. Then Pascaline was developed in 1642 by a French mathematician called Blaise Pascal. This is how the Pascaline looks like, and it has movable gears that could add, subtract, multiply and divide the numbers very easily. Then we have Leibniz step reckoner. In 1692 this was developed. Again it could perform all four basic mathematical operations: addition, subtraction, multiplication and division. So as we see, as we are gradually going down the hierarchies, we see that the devices are becoming advanced. So first we could only use them to add or subtract, then we could add, subtract and multiply. Now in this step reckoner we could also divide the numbers. Then we have Babbitt's Analytical Engine. In 1822, a mathematics professor of Cambridge University, England, he developed a machine known as difference engine. So he developed a machine called difference engine, how it could perform mathematical operations automatically. However, in 1833, nearly 11 years later, he had a better idea and he stopped working on difference engine and started designing another machine called Analytical Engine. It had 5 key features. So this machine is special. Why? Because it has input device, storage unit, processor, control unit and output device. Now all these things are found in our modern computer. Now we'll see about a tabulating machine. So Herman Hollerith in 1890 invented a machine which was used to count the population, or used in the census of the USA, and it gave a quick count of the US population. So why this machine was used? Because it extremely fastened the procedure of census, and which is usually a very lengthy procedure. And this machine was so successful that the Hollerith formed a company that later became famous as International Business Machine, or IBM. So this machine was so successful that the man founded the company IBM. Now we look at the electromechanical computers and first electronic computers. So Mark 1. In 1944, Professor Howard Aiken built the first electromechanical computer named Mark 1. What was the speciality of this machine was that it used a typewriter for input and punched cards for output. This device was the first computer in a real sense, something that used as a keyboard, a typewriter, and used input and provided us output. So this was the speciality of this machine, and it was a computer in a real sense for this reason only. Then we see the electronic computer, ENIAC and UNIVAC. John Mauchly and John Presper Eckert together built the first successful electronic digital computer. ENIAC, full form for which is Electronic Numerical Integrator and Computer, and it was operational in 1946. This machine was 10 feet wide and 100 feet long. It occupied 1800 square feet of area and could perform 5000 additions per second. Now this is an achievement in itself. 5000 additions per second. So as you see, gradually as we're going down, the computers are becoming faster and capable of more and more operations. In 1951, John Mauchly and John Presper Eckert developed another successful computer known as UNIVAC, Universal Automatic Computer. It could handle both numeric and textual information. It was the first commercial computer delivered to a business client in 1951. Now, after all this history, we come to our simple personal computer. Computer has come a long way since then. In 1981, IBM introduced its first personal computer, and in 1984, they introduced the advanced version of personal computer called PC-AT, PC Advanced Technology. Now, these computers were smaller in size, faster in speed, and more accurate and more reliable. That was the basic advantage of these computers. There are several types of personal computers available nowadays. For example, desktop, laptop, and tablets. We have already studied these types in our previous classes, and we already are aware about these. Now we will study a bit more about the generations of our computer and come to the very present generation of our computers. So, generation. Dear children, we all have different generation of people in the family, like grandparents, parents, and children. Even computer also has its different generations, like so the first one goes back to UNIVAC. Then we see personal computers, desktops, all-in-one, notebook, and like that. And finally to Raspberry Pi. And I want to know how many of you are already aware about Raspberry Pi. They're divided into 5 distinct phases. So let's begin with the first generation, which began from 1946 to 1958. Okay, the makers of these computers used thousands of vacuum tubes which look something like this, which were often huge and taking up the space of an entire room. So the earliest computers used a space of an entire room. They used machine language, the language of 0 and 1. They used vacuum tube technology. The size was very big, they were very expensive, they produced a lot of heat. So all such things you have to learn about these machines. Then we see the second generation computers. They used transistors, they used assembly languages, they've got some basic commands like add, sub, and things like that, but they're typically not 0 and 1. So the cost got reduced, the size became smaller. So all these features are important because we are making progress by the generations. Now you'll see. So what are the examples of this second generation? The transistors were far superior than vacuum tubes that allowed computers to become smaller, faster, and more reliable than the first generation computer. Size difference between a vacuum tube and a transistor. So you can see the comparison here. One vacuum tube is equals to 40 transistors. Now that's an achievement again. Now we'll see about the third generation computers. In the mid of 1960s, the development of the integrated circuit was a major breakthrough, and which resulted in the introduction of the third generation computers. The transistors were replaced by the ICs, also known as semiconductor chips. What are the features of the third generation computers? They used integrated circuits, very important. The size became extremely small because chips are small, very small, size like this. They generated less heat and were more reliable. By reliable, we means that they were more accurate. The calculations that they performed were more accurate. They performed billions of instructions in a few seconds. Users interacted with keyboards and monitors which interfaced with an operating system. So operating system was the feature of these third generation computers, and they use high level languages like Fortran and COBOL. Fourth generation computers. So they started in 1971 and they use microprocessors. So now we have come from integrated chips, that is IC. From that we have come to microprocessor, which is a single chip that does all the processing. It looks like this. See, it's just small and it fits on your fingertip. So what are the features of these fourth generation computers? They use high level languages like C, C++ and Java. They use they're multi-purpose computers. They can do anything. They are accurate, reliable and very fast. They use microprocessor, which is a chip like this. So for example, Macintosh, IBM 370, Intel 4004 are key examples of the fourth generation computer. So in 1981, IBM introduced its first personal computer that looked like this. So this is a system unit, but it is placed horizontally just below the monitor for the home users in the 1984. And during this time, Apple introduced Macintosh. Now, fifth generation computers is what we will talk about, and with which our chapter will be over. So fifth generation computers are based on artificial intelligence. They are still in development, and all these robots, so fifth generation computers are the ones which can be found in present or beyond. They are a very futuristic approach. They are based on artificial intelligence and they are still nascent. They are developing. Have you seen the devices such as Google Home or Alexa, whereby they are capable of learning and taking their own decisions? They can respond to us in a very natural way. What are the features, you may ask? The fifth generation computers will use super large scale integrated chips. They'll have artificial intelligence. Yes, they'll be able to recognize images and graphs. This is already started to happen, that our computers are able to distinguish between and recognize images and graphs, because human brain, while all these things are very easy for them, these things are extremely complex for a computer's brain. So now with all these advent of so much of technologies, this change is coming up and they can now recognize images and graphs. They'll be able to solve highly complex and critical problems, including decision making. So decision making is something that is very easy and common for a human being, but we're now developing computers that can take decisions on their own. I hope you really enjoyed learning this lesson about all the history and future of our computers.